Okay, hello everyone, and welcome to today's webinar. Thank you for joining us today on our webinar, What's the Difference Between Jenkins and Spinnaker? My name is Bo Roberts. I run marketing at OptumX, and I'll be the host for the webinar today. Just a little housekeeping before we get started. If you have any questions during the presentation that you would like us to answer, please type them into the question box in the GoToWebinar control panel. We'll address questions during the presentation if it's appropriate, but most questions will be answered during the Q&A at the end of the presentation. Also, I would encourage you, if you have a question, try to type it in during the presentation so that we have some questions when we get to the Q&A. Oftentimes, people will try to type them in when we get to the Q&A, and that's fine. But if you have a question, it's helpful for us if you type it in before the Q&A. Okay, let's get started. I think that's it. So let's get started. For those of you who may be new to OptumX, anyway, we're a Silicon Valley-based startup. We're based in Sunnyvale, California, and we help enterprise organizations modernize and transform their software delivery with Spinnaker. We provide an enterprise-ready distribution of Spinnaker called Open Enterprise Spinnaker, and we also offer a managed Spinnaker service, as well as onboarding, training, and support services that help enterprises adopt and scale continuous delivery with Spinnaker. So with that, let's move on. And next thing we're going to do, we like to start off our webinars asking a couple poll questions to get a sense of who's in the audience. This helps our speaker, our presenter, kind of tailor the presentation a bit for who's in the audience. So I'm going to put up a couple poll questions very quickly, and I'll share the results with you. First question is, are you currently doing continuous delivery? And if yes, with what percentage of your production applications? And we've got the choices are dev and test only, less than 10%, less than 50%, more than 50%, or you're not doing continuous delivery. If you could just quickly, it's completely optional, but if you can answer that question, that'd be helpful, and we can show the results to see who's in the audience. Okay, we still got a few people voting, but I'm going to close this in just a few seconds. So if you'd like to vote on this, please do so. And okay, I think I'm going to close the poll now. Okay, and let's see. It's like we've got we've got a pretty good distribution of people not doing continuous delivery and some who are, so that's good. Next question. Next question is your organization currently evaluating or using Spinnaker? Are you evaluating it, using it in production, not in production, or maybe not evaluating Spinnaker, or not using it and not evaluating it at all? So anyway, if you could, same thing, it's totally optional, but if you could answer the question, I'll share the results. We'll see who's in the audience, and then I'll turn things over to Srinivas, our speaker for today. Okay, we've got people still voting, but I'm going to close the poll in a few seconds. Here we go. Okay, so it looks like we've got a good distribution of people as well here using Spinnaker and not using Spinnaker. So with that, I'm going to turn it over to today's speaker, Srinivas, who's a senior DevOps consultant here at OptumX. So Srini, I'm going to turn it over to you now.
Thanks, Bo, and thanks to all of you for joining this webinar. I'll quickly go through how DevOps has come into being in my own experience of the last 30 years, from the days when DevOps didn't exist and source code control didn't exist. And we'll just see how it has developed and what are the common patterns we see at every stage as things move forward. So the initial days when we used to do the development, I mean, source code control and configuration management was actually not there. We used to share files and emails and, using FTPs in those days, floppies. And some of those of you who might be have the experience of using floppies and other kind of media, we used to share files in those. Then as the mess became higher, version control system came in, a new tool, the first tool, RCS, CVS, and so on. And then came ClearCase. ClearCase came much later, like a multi-branch development. In those days, it's a big thing. And then we used to write scripts around controlling check-ins. How do we prevent someone from checking in? How can we prevent one guy from breaking the whole build, and so on and so forth. Then we had more scripts for approvals, reviews, and so on and so forth. And essentially, we had scripts and tools to deal with things as they evolved. Till, of course, now you have GitHub, for example, where a lot of these things are already built in. And now we have, repositories and artifactories. So if you see build management, we used to do it manually before. There used to be shell scripts to automate, builds, and then these the scripts I wrote in those days would send out an email notification whenever the build fails or completes. And then we used to have specialized build servers, and then more controls in place to decide who can build, when things should not be built, and so on and so forth. And a lot of these scripts later on got replaced with Jenkins. Jenkins is open source, it's free, and it pretty much handles everything you can think of in terms of doing builds. But Jenkins essentially was like the culmination of all these scripts and specialized things that used to break pretty frequently. They were, at one point we had a team of 15, 20 people only handling all these builds and, scripts. And we had kind of become experts in that. Deployment today. How are the people deploying? You have command line interfaces, the people specialized skills. Deployments mistakes also happen, and then more scripts. Some of these scripts go into Jenkins pipeline, and essentially things keep, the scripts become like a mess of. It becomes a project in itself. Added to that, we also have an additional dimension of cloud deployments. Cloud has added a different dimension to the complexity of deployment, because now you have command line tools, APIs, and so forth. And particularly if something changes, API versions change in the cloud, or if we are moving from one cloud to the other or on-prem to cloud, a lot of these efforts that we put in for the scripts and all pretty much go waste. And what's been called scripting hell results in, strange defects and people spending time trying to understand what happened. So now probably is a very good time to take a quick look as to how are we deploying today in our organizations. This would be a very good one. Bo, can you please conduct this poll?
Srini, we actually don't have that poll ready, so I think we're gonna have to go without it today.
All right, no worries.
Okay, sorry about that.
No worries. So sorry about that, guys. Just wanted to tailor my conversation around where people are with respect to deployment. During this time, when cloud and things have changed in terms of deployment targets, A lot of other things have changed. Let's take a quick look as to how things have evolved over time in terms of computing environments. Before there were servers, then there were blades and racks. Then we had, license-based CPU memory provisioning, virtual machines. Then we had automatic virtual machine provisioning. And then came Amazon Cloud, Cloud Foundry. Containers came later. And just around the time microservices came in. REST, was designed or defined in 2007. They came into a prominence much later, and then with containers, microservices, and REST, the entire application architecture has changed. In the meantime, now we have multiple cloud providers: Google, Azure, Amazon, and so forth. And then these cloud providers are, of course, competing for the market share. And sometimes Azure, for example, if it's doing a very good deal, we may be asked by our managers to switch from one cloud to another, or use multiple clouds all at the same time. The number of VMs nodes is also going through the roof. The servers of these dimensions, in my days when I handled a server room with 6 feet racks and blades, occupying order of like 200-300 square meters space was considered a reasonably large data center. And in today's day, if we see that that's not even a baby data center, it's a very small data center compared to the kind of data centers being operated by various providers. So the number of nodes, number of virtual machines has increased substantially, gone into hundreds and thousands. And then that has resulted in different types of scripts, Ansible, Puppet, Terraform, and so forth. And then we have cloud storage and services. Suddenly have a cloud-based database, identity and access management, and so on and so forth. Dynamic load balancing, firewalls, network provisioning, infrastructure as code, auto scaling, fault tolerant, auto healing, and then you have Kubernetes and its various flavors, on-prem, multi-cloud providers. You can see that as these things have changed, Jenkins was never designed for this. Jenkins was designed to do builds, and things have changed substantially after that. One of the other things also that changed is what users are expecting. I think in 1997, for the first time, I had an online bank account. And it was so cool that I could go home after office and then check my bank details, do some transactions. I don't have to take time off from work to go to the bank just to check my balance or, communicate with the bank or whatever. That was really cool. But now the expectation is 24/7. Nobody in those days, anybody realized that we'll be having users at 2 a.m. or 3 a.m. complaining that some online transaction did not happen. But now it's a reality. And the expectations from people has changed, that everything is going to be instant, 24/7, always available. This is where the user expectation is going. If I'm watching a movie on Netflix or anything, I don't expect it to be interrupted because somebody was doing a software upgrade. That's absolutely not acceptable. At least from a user perspective, we expect, in most of you who are, online and you are experiencing things now, when has, Netflix been shut off for upgrade? When has YouTube been shut off for upgrade? Google, Yahoo, you name it. WhatsApp, if there is a 1-hour outage, that's news. It comes actually in the printed news. So 24/7 non-stop services is the lifestyle expectation of today. Once again, many of the applications people are using Jenkins in particular was never designed for this. So let's take a quick look at the overall process. We have continuous development by developers and source being checked in to RCS, CVS, GitHub, and so on and so forth. Then we have building this, continuously building this changed code into new jars or objects or whatever that might be. And then you have continuous integration, where you have multiple teams making changes across multiple streams, multiple services, and then we are integrating all of them into one usable application. This is where the technology was till yesterday. Now we talk about continuous deployment. Spinnaker is designed ground up for continuous deployment. And then we'll briefly look at Autopilot, which does a machine language-based verification. So this is roughly how code changes from developers go all the way to customers. And the longer it takes, more time is being spent and less efficient the whole system is. So what is Spinnaker? It's a tool designed and built ground up for deployments. It was developed by Netflix as an internal tool and open sourced 3-4 years ago. And it's still supported big time by Netflix, Google, Target, among many others. Most important thing is that because Spinnaker is a deployment tool, it does not say something is deployed because the command got executed. Let's take a quick comparison with, let's say, with the Helm deployment. What Helm deployment does is it takes, in the case of Kubernetes, for those who are aware of what I'm talking about, it executes a command, and if the command executes successfully, it says application is deployed. That's not what Spinnaker does. Spinnaker does a lot more. It goes and checks if the application is up and running. It's checking if the network routing is happening properly, and if the application is essentially available to customers. So Spinnaker makes sure that the deployment is safe, that it has happened, and the application is actually available to users. It's open source, free. Over 6,000 developers, including us, are actively working on improving the product. Excellent documentation. It's very well integrated with Jenkins, a host of other tools which are normally used, such as LDAP or AD, Microsoft AD for authentication. At a native level, built-in, it supports Kubernetes, Amazon, Google, Azure, Twitter Cloud Foundry, and a lot more. These are all built into it. The tool itself makes it required API calls, making it very, very easy for a non-technical person to use and deploy applications on these clouds. Spinnaker also supports role-based access control. One of the common problems people are facing is that we want our developers and testers to be able to deploy the application anywhere, but not production. Deploying to production typically involves additional controls. It involves approval processes and so on and so forth. With Spinnaker and rollback access control, it's possible to have one pipeline that can deploy to different environments based on who the person is who is pressing the button on the screen. And that makes it very, very convenient to run a pipeline all the way from development to production. Some of that RBAC features also include that developers can see production logs, for example, without having access to the production environment itself. In my experience, it's extremely rare that we want to give developers access to the production environment. But here, it makes it easy for them to see the logs in the production environment without being able to do anything there. It has predefined time windows for deployment to ensure blackout periods. Clusters, load balancers, and firewalls. All of these are integrated into the tool itself, because Spinnaker was built ground up for the cloud age. All these infrastructure elements are part of the application, and one can see, for example, if you are using any of the cloud providers, load balancers get charged for, and you can see how many load balancers are there, where the traffic is getting routed to which applications, and so on and so forth. It supports blue, green, and red, black kind of deployment strategies, canary deployment, if you're aware of that. The Spinnaker application itself is microservices based. It's highly scalable, high availability architecture. It also has webhook, custom stages, and custom integrations, so it's easily extendable. So if it is not integrated with some particular application you're using now, it should be fairly easy to integrate with that. Most of the common applications such as GitHub, Jenkins, and so on and so forth are already natively integrated. And with webhook particularly, it's possible to integrate to a host of other applications that you might find in your ecosystem. It has very good backup and recovery, and supports pipelines as code and pipelines as templates. Pipelines as code makes the whole the architecture of the entire DevOps, it takes it to a new level. Even if the entire Spinnaker instance that we are currently using were to be blown away, we can set up the entire thing back, including all the pipelines, in less than an hour, because all the pipelines are stored as code in GitHub, and all we have to do is bring them back, and we are set. So this is pretty much the future, where we want to have very high reliability with respect to our deployments, frequent deployments, and safe deployments. I'll very quickly touch upon the last topic here for today, Autopilot. We saw how scripting and get converted into tools, and tools become more mature and become the de facto standard, as Spinnaker has become today after Jenkins were built. For verification, what we have is a tool we call Autopilot. At a very summary level, what Autopilot does is it analyzes the logs and metrics of an application that is running and compares it with the baseline. The baseline could be from the same application in time, or it could be another branch of the application running elsewhere. And by doing statistical analysis and a machine learning based algorithm, it gives a score that says how safe it is to go ahead with the deployment or to continue with the deployment. So because of this two set comparison of metrics and logs, it presents a lot of interesting use cases. As I said, when Jenkins will ensure that your build happens nicely, Spinnaker ensures that it's deployed nicely. And once it's deployed, for example, the application consumes 25% more CPU. How would we know that the application is consuming 25% CPU? It has already passed all the functional tests. Autopilot will catch it straight away because it's monitoring the production, the metrics, and comparing it with the baseline set of metrics. It's going to tell you that yes, it's not safe to go ahead. Something is not right, and it'll reduce the score. So it can confirm that the deployment is safe. It can help with production issues by analyzing metrics and logs after a production incident has happened. So we can take a baseline and compare it with the production metrics during the time window at the time when the incident happened to gain more insights into what might have gone wrong. Sanity checking a new build before testing team spends manual time and effort on this. Building a historical log and gaining insights. So it has a host of use. Roughly, I have what I have for today. There are a lot of resources on Spinnaker on the internet. And Bo, over to you.
Okay, Srini, thanks. That was really good and interesting. Yeah, we're going to do the Q&A now. So if you have a question for Srinivas that you'd like him to answer, please submit those questions in the question sort of box in the GoToWebinar control panel, and we'll take as many questions as we can. Before we move to the Q&A, Srini, if you could move to the next slide. Hello, Srini, could you move? Yeah, okay. Yeah, before we move to the Q&A, one of the things I like to do before the Q&A is oftentimes people ask us for the presentation slides, and we don't post them publicly, but we're happy to send them to you after the webinar. So as well, I wanted to just make you aware of things that we can follow up with you in case you're interested. So I'm going to put up a quick poll, and basically, yeah, if you'd like to be sent the presentation, you can select that. Some other things that we can follow up with you about if you're interested. So about Spinnaker training, onboarding, or support. If you'd like to schedule a demo of our enterprise-ready distribution for Spinnaker, OpsMex, Open Enterprise Spinnaker, you can do that. Or we also offer complimentary continuous delivery strategy workshops, which are basically 2-hour Zoom sessions with one of our CI/CD experts, and they will walk you through sort of the planning framework that we use with our clients. Those are pretty popular. So anyway, I'm going to leave this up for a few minutes while we get the Q&A started. And if you'd like us to follow up with you about any of those things, you can just indicate that right there. So Srini, let's start off with the first question. First question we've got is, can Spinnaker be used without Jenkins or any CI solution?
Yes, it can certainly be used without Jenkins, any CI solution. Typically, one possible way to do it is that if you are using Kubernetes, then most of the Jenkins jobs can be run as Kubernetes jobs. Once again, it can be done. That is not what we are recommending. If there is a reason why, for example, you are doing only simple builds and don't want to use Jenkins, then it's possible. But the Jenkins is purpose built for builds, and Spinnaker is purpose built for deployments. So they are kind of complementary to each other. So is it really possible to go ahead and run pipelines without Jenkins? Certainly, yes.
Okay. Okay, let's see what the next question is. Let me see here. Okay, we've got another question here. Can CI/CD pipelines be built using only Jenkins?
Yes, someone has definitely been thinking about it. The thing is that yes, and in fact, I think if our opinion poll shows, it's possible that quite a few of our audience are actually doing that. So what they are doing is that you have a race car that you go and use it for shopping or something. So you're just using it for the wrong purpose. So you have Jenkins, and then yeah, whatever scripts one would manually execute, one could plug them into Jenkins and then run it and say, hey, it deploys. But that's just a script running, and that could, obviously not have the robustness that Spinnaker or a custom built tool would have.
So, so is that sort of what gets people into that kind of that state of having to maintain all of those scripts over time?
Yeah, typically this starts as a very one or two line, oh, it's so easy to deploy kind of script, and then you start copy pasting it, and then after some time it grows into 10 lines, and then 2 files, and then you suddenly realize that there is a team of people only maintaining these scripts, and this scripting hell that many growing companies face. And Spinnaker can make sure that we start right.
Okay, interesting. Okay, we've got another question. Yeah, to the audience, I'd just like to reiterate, if you have a question, please submit it now, so we can get to your question. Otherwise, we'll move on. Okay, the next question, Srini, is can Spinnaker be used in an OpenShift environment?
Yes, certainly it can be used in OpenShift environment. In fact, OpsMX is the only provider to give a Red Hat certified OpenShift operator that's available for anyone to install and use in an OpenShift environment. But I must note that OpenShift environment is rather restrictive in many ways. So if we are going to install and use Spinnaker in OpenShift environment, there are quite a few extra steps needed to configure Spinnaker so that it is allowed to operate as expected in an OpenShift environment.
Okay. Let's see here. Yeah. Let's see if we have any other questions. I don't see any other questions right now. Well, let me give everybody one last chance to ask a question. Srini, if you have any sort of closing thoughts on this subject, we can do that now. Otherwise, we if we don't get any other questions, we'll probably wrap things up.
Yeah, absolutely. So while we wait for people to type in their questions, to come back to the title, Jenkins versus Spinnaker, essentially it's not a comparison. It's just that people think that, I have Jenkins, so why do I need Spinnaker? Because that need has not been felt yet, because in most cases need comes only with suffering. And Jenkins was designed well before cloud existed. It was, Jenkins came up sometime in 2007, I believe, or 2005. It has evolved since then. I'm not saying that it has not evolved, but it was never designed for deployment. It was designed to do and build pipelines. And those days, that was really heavenly to have Jenkins. I still remember in 2002, 2003, for us to be able to do builds, we had our own scripts. And we were toying the idea between writing the scripts in Shell versus Perl. In those days, Perl was like one of the hotter languages coming up. And Spinnaker, on the other hand, written in Java with microservices architecture, HA by design. So it's what we are talking about. The expectation from our developers, from our users, everyone is that everything is working 24/7, and we can't go and explain to someone saying, oh, why the build didn't happen, or because our build server died or something went wrong. These explanations are becoming more and more rare, because the social expectation is that everything should always work and things should continuously be working even as we are upgrading. and Spinnaker is designed for that. So Jenkins and Spinnaker are very, very complementary. They complement each other in terms of functionality, but they're not comparable.
Okay, all right. Okay, let's see. I'm not seeing any other questions right now, so I think we are going to wrap things up. Just a couple last thoughts. As I mentioned, if you need any help on any of this stuff, feel free to reach out to us. You can see on the screen the email address hello@OpsMX. We monitor that email address pretty closely, so reach out to us if we can be of any help. And another thing I'd like to encourage you to do is we're doing a lot more webinars these days with everybody sort of working from home and stuff. So I'd encourage you to go to opsmx.com, check out our webinar calendar. We've got our next webinar is actually coming up next Tuesday on June 9th at this same time. It's called Why Spinnaker in Kubernetes, and should be an interesting topic. So hopefully we will see you there. Once again, I'd like to thank everybody for joining us today, and we hope to see you on a future webinar. Take care.